Okay, example 1. Okay, we have here function 2x cubed plus 3x squared minus 12x minus 1. Okay, you have to find what is your relative maximum and minimum using the second order derivative test. Okay, so means you have to use SDT, second order derivative test. Okay, now remember first step, we have to find the critical values. Okay, the critical values means you have to differentiate first. F prime x equal to, from this function, 6x square plus 6x minus 12. Right? So then you have to set f prime x equal to 0. And another one, set f prime x equal to undefined. Okay, so this one, okay, we do not have the denominator, right? So denominator equal to 1. It's not equal to 0 means that we have the, okay, we do not have critical points from the denominator part. Okay, from this one means we have here 6x squared plus 6x minus 12. Right? So you press your calculator, we can take out, okay, 6, and then here we have 6 x squared plus 6 minus 2 equal to 0. Okay, so 6, and then this one you can factorize, we can get x plus 2 x minus 1 equal to 0. So equal to 0, here we get, okay, 6, we bring to the right side, we get 0, right? 0 divided by 6, 0. So this one we have x equal to negative 2, x equal to 1. So this is your critical points. We have 2. Okay, so CP equal to x equal to negative 2, x equal to 1. Okay, next step, we have check what is your domain. Okay, so domain from this function, we know that this is all R, all R, all R. So our domain is all R. So means that you can take all of this. Okay, we have 2 critical points. Okay, number 2. Okay, we can say that since x equal to 2 and x equal to 1 lies in the domain, so this is, okay, this is a CP. Alright, critical points. Okay, step number 3, you have to find what is the second order derivatives, okay, from this function. Okay, this one is first order, and then we differentiate in second time, define the second order, so we get 12x plus 6. Okay, so second order. Now we want to try, okay, we substitute the value when, okay, x equal to negative 2. Okay, substitute into the second order derivative. Okay, you get this one, oops, okay, negative 24 minus 12. Right, so means you get negative value. Okay, negative value means your graph will be concave downward, concave down. So you have here relative maximum x equal to negative 2. Okay, so substitute another one, we have here when x equal to 1, okay, our critical points into this function, we get 12, 1 plus 6, 1. So here we have 12 plus 6, we get positive value. So means that your graph will be concave up. So here we have x equal to 1, right? So our relative maximum, relative minimum is at x equal to 1. So this is the answer. That's all. Okay, easy, right? I hope you understand. Okay, I will do some review, not the review, very short notes for this topic. Okay, first step, we find the critical values by using the first order derivative. We set the Okay, we set the f prime x equal to 0, f prime x, and define this one just to find the critical points. Okay, just to find the critical points. Once you get the critical points, you have to check the critical points must be lie in the domain. Okay, then next step is, what is your domain? Okay, once you get this one, pass. Okay, this critical points inside the lies in the domain, so means you can proceed the next step, where you have to differentiate using second order, and then substitute all the critical points into the second order derivatives. Once you get negative, means the graph concave down, so we have here relative maximum when at x equal to -2. If your graph is positive, if you substitute the value into second derivative, you get positive, so means that your graph will be concave out. You get relative minimum here, x equal to 1. Okay, so inshallah this topic easy. Okay, it's simple. Okay, maybe after this you can try all the exercises. Okay, inshallah. Okay, I hope it helps. Okay, thank you.